Continuous versus discrete data. So let's do some definitions. First, let's talk about what continuous means. Continuous data is data that can take any value. Whole numbers, decimals, fractions, infinite fractions. So basically this means that fractional pieces are reasonable. Fractional pieces are reasonable. And if you're looking at a graph, these are graphs that are a single unbroken curve. So data that can take any value, fractional pieces are reasonable, and graphs that are a single unbroken curve. Now, discrete is basically the opposite of all of that. This is data that can have specific values. Data that can take only certain values. It could be a fraction, but not all fractions make sense. But for the most part, fractional values are not reasonable. And we'll talk about the one exception to this rule. And then finally, the graphs have unconnected points. And we like to call those kinds of graphs, we call them scatter plots. That's basically what discrete data is, it's scatter plots. So let's look at some examples of the two. So let's look at an example of, let's talk about discrete. So discrete examples. So I'm going to make my little section and I'm going to highlight. Okay, so if we talk about graphs first, it might look like this with your X and your Y, just like a single quadrant, and you've just got kind of a bunch of points hanging out everywhere. Okay, that's an example of discrete data. You could also have all four quadrants, and you could have points everywhere. The big idea is that these are not connected. They're all individual points. If we start talking about real world, okay, well, these are things that are counted. Things that are counted. That's usually what falls under discrete data. If it's counted, that's discrete. So you can also think of that fractions are not reasonable. For example, so let's look at a couple of examples. If I talk about the number of desks in a room, okay, I can't take half of a desk. You either have one or you have two, not 2.5. So that's why fractions don't make sense here. And I count a desk. You have 1, 2, 3, 4 animals, people, basically items or objects. That's the big thing. Now, here is the one thing that actually has fractions and it makes sense. Money is discrete, okay? But you can have technically half a dollar, it's 50 cents. But if you try to take half of a penny, you can't have half of a cent. So some fractions are reasonable, but not all of them. That's what makes money discrete and not continuous. Yes, you can have fractional pieces of a dollar, but eventually you can't cut it in half anymore. Like a penny, I can't cut a penny in half. That's as small as it's going to go. So that means money can only take certain values, which makes it discrete. Now let's talk continuous. So for some continuous examples, let's look at some graphs first. So with discrete, they were all unconnected points. With continuous, they are a smooth curve. So this is an example of a continuous graph. You can draw the whole thing without ever having to pick up your pencil. Now, Another example of a continuous graph is this. So this is x, this is y. You may have points like this. But the fact that all of these points are connected, that's what makes this continuous. So just because you see coordinate points plotted doesn't mean it's discrete. Since they are connected, that's what makes this continuous. So now let's talk about some real world. For discrete, they were things that were counted. For continuous, these are things that are measured. Things that are measured is a good idea of the continuous. And in this case, fractions make sense. So, for example, if we talk about distance, we measure distance in, like, let's say feet, miles. I can have 0.2 of a mile. I can have 0.8 of a mile. I can have 0.22222 repeating of a mile. So every fraction possible for miles is it works. Time is also measured. I can have 0.5 of a day, 0.2 of a day, 0.3 of an hour. Things like weight, length, anything that you actually measure, like a unit, okay? Volume works, there's all kinds of things. So continuous things are measured, discrete things are counted. That's a pretty good way to tell the difference between the two. So here's kind of what we're going to do with this. For example 1, the weight of cheese W depends on the number of gallons of milk M used. So we have this equation here that represents the situation. W equals 16 times M. So the weight of the cheese will equal 16 times the number of gallons of milk used. So the first thing we're going to decide, so part A, is we're going to decide, is this discrete or is this continuous? And why? Okay, so let's see what we have. So we are working with weight and we're working with milk. Gallons of milk and weight of something like an ounce. It didn't specify for this one. Those are both things that are measured. So since both weight and gallons are measured, both of these can have any decimals, any fractions, any whole numbers, any values they want. That makes this continuous. Continuous because weight and gallons can take any value. Whole numbers, decimals, fractions, whatever it needs. Okay. Now the second thing we're going to do is, because it's continuous, we're going to actually graph it. But to graph it, we have to do something else first because we don't know how to graph a lot of things right now. So we're going to have to use this table to help us plot some points and to graph. So we're going to take the given values, the independent values, that's my M. So it says the weight depends on milk. So that means that milk is my independent. Which is kind of like X, which makes weight my dependent, which is kind of like Y. So what we're going to do is we're going to take my M values, plug them in to find the weight value. So if I substitute a 0, I would have 16 times 0, and that makes 0. So my first weight would be nothing. Then I would times 16 times 1, which would give me 16. I would do 16 times 2, which would give me 32. 16 times 3 to give me 48. And 16 times 4 to give me 64. Substituting my M values to find my W values. Okay, so now that we know that, we can kind of graph this as best we can. So let's label our axis. So this down here will be, this is like your X, this is your M. This is your independent axis. So this is the gallons of milk. Gallons of milk. And this is your W. So this would be your weight. Weight of cheese. Okay. So I have to get all the way from 0 to 4 on my x's. Well, that's easy. 1, 2, 3, 4, 5, 6. Perfect. 1, 2, 3, 4, 5, 6. All right. My W axis is 0 to 64. So it's going to take a little bit of thought. Okay, if I go by 10, that should be enough here. So if I do 10, 20, 30, 40, 50, 60, 70, 80, so that's plenty. Okay, so now let's plot some points. So at 0 gallons, I have 0 weight, so that's a point here. At 1 gallon, I have 16, so 10, 20, so 16 is about here somewhere. Okay, 2, I have 32, so here's 30, 32 be right above 30. At 3, I have 48, so here's 40, 50, so 48 would be about here somewhere. Okay, and then 5, I have 64, which should be around here. Now, the question is, do we connect them or do we leave them as data points? Because we said this is continuous, that means this needs to be connected together in a line. So connected because it's continuous. Connect because continuous. This line tells us that any of these points, anything on this line right here is going to be a solution to this situation. I can have 2.6 gallons of milk and that's going to give me a certain weight. I don't have to only have whole numbers. So if I have 5.5, I can have something like 80 or so weight of cheese. Okay. That's what this solid line means, is all of these points are reasonable solutions to this situation, which is why we connected them, because they make sense. I don't have to only have the whole numbers. Let's look at another situation with this cheese. We're still going with this cheese situation here. So let's look at example 2. Example 2, the amount of money made A from selling N full cheese wheels. Okay, so first question, is this discrete or continuous? And why? So let's think. I have the amount of money. I have money. I know that's discrete. And I have N full cheese wheels. So think about full cheese wheels. What that means is I'm going to sell a whole cheese wheel or 2. I'm not going to sell 1.5. So this is also discrete. Now, if you have something that's discrete and continuous, the discrete is the one that wins out. So if you have discrete and continuous, the overall is the discrete, because I can only have certain values for my discrete stuff. Continuous can take anything, but discretes can only be certain values, which is why discretes will win if you have both. Okay, but since these are both discrete, the overall is discrete. And it's mainly because I'm only selling full cheese wheels. Okay, now again, we're going to graph it. So we're going to use our table and our equation to help us graph. So we're going to need to substitute in the A values to find out how much money we're making. So if I substitute, oops, these are backwards. So let's talk about why these are backwards. Okay. The number of cheese wheels controls the amount of money you make. So the cheese wheels is the independent. So that's why they were backwards. A is the dependent, because you don't make money unless you sell cheese wheels. So these guys are backwards. I had them backwards. So here we are. So now I have 0. If I sell nothing, well, if I plug in 9 times 0, I get 0. That makes sense. If I don't sell any cheese wheels, I don't make any money. So now let's see, 9 times 1 cheese wheel, I would make $9. 9 times 2 cheese wheels, I would make 18. 9 times 3 cheese wheels, I would make 27. And 9 times 4 cheese wheels, I would make 36. So again, let's graph. Let's draw our little grid here, our little axes. And I only need the first quadrant because this is real world stuff. So our independent axis is the N, that's your cheese wheels. So I'm going to say just number of cheese. And then our dependent axis is the A, that's the money made. So that's your money. Okay. Now, on the N axis, we just have to go from 0 to 4. So 1, 2, 3, 4, 5. On our a-axis, I have to get up to 36. So I could maybe try 5s or 2s. I'm actually going to do 3s. 3s may be easier. So 3, 6, 9, 12, 15, 18, 21, 27, 30, 33, and 36 right at the very top. Okay, so now we're going to plot our points. So we have 0, 0. So if I don't sell any cheese, I don't make money. I have 1 and 9, 2 and 18, 3 and 27, 4 and 36. Now, we do not connect these because we said earlier I can't sell 1.5 cheese. Since I can't sell 1.5 cheese, this coordinate point here is not going to be an option. So since it's not an option, I can't connect these points. So we're going to leave these as disconnected because we said it was discrete. So when you have a continuous situation, you connect the points. If you have a discrete situation, you keep the points separated.